Hey, in this Unreal Engine 4 tutorial, we're going to set up a base character blueprint that we could use as a parent for any of the Paragon characters on the Unreal Engine 4 marketplace. You can find documentation for this tutorial at the description below or on my website. And with that, let's just jump straight to it. So to get started with our base character blueprint, I'm going to create a new blueprint class in my blueprints folder, and it's going to be a character type. I'm just going to name this base character underscore BP. Let's open up this blueprint. And let's start by adding in a mesh. I'm going to select the mesh slot. I'm going to drop down the skeletal mesh, and we can choose any character from Paragon here. I'm just going to choose Countess. We can see that the character is floating. I'm just going to bring it down so the feet hit the bottom of the capsule, and we can rotate it -90 on the yaw. Now let's move on to setting up the third person camera. To do this, we're going to attach the camera onto a spring arm. So let's come up to Add Component, and type in spring arm, and we're going to move this up and rotate it so it's behind the character. Now to add the camera, we want to make sure we've got the spring arm selected, and then we're going to add a new component, and we're going to add in the camera. And we can see that when we select the spring arm, the camera is actually attached onto the end of it. Now if we want to change the camera's position, we don't want to move the camera or the spring arm. Instead, we want to adjust this target arm length value here. And if we want to make an over-the-shoulder view of the character, we can actually use this socket offset. We don't want to do this here. We want to select the spring arm and just put in a value. I'm going to use 64. And now we can see that the spring arm has offset to the right side of the character. Now we're going to make it so when we look around with the mouse, the spring arm is going to pan around the character. So to do this, we want to make sure we've got the spring arm selected, and we'll check Use Pawn Control Rotation. To stop the character from rotating with the camera, we can hit the Class Defaults button and uncheck Use Controller Rotation Yaw. And one final thing we want to do is make the character rotate in the direction of our movement. To do this, we'll select the character movement component, and in this bar here, we're going to search and filter for rotation, and we're just going to check Orient Rotation to Movement. And now we can switch over to the event graph and start setting up our movement code. So to get started with our movement input, we need to make sure we've got some input mapping set up. We can do this by coming up to Edit and Project Settings, and then by coming to the Input tab. Now you can pause the video here, or check out the documentation for this tutorial to copy my settings. And once you've set up your mappings, we can close this, and we can continue by getting the Move Forward Axis event, and also the Move Right Axis event. To add movement input, we can use the Add Movement Input function, and we're going to duplicate this with Ctrl W for the Move Right. We're just going to make sure the execution pins are connected together and that the axis value is connected to the scale value. Now for the world direction, we are going to get our control rotation. We're going to filter out the roll and the pitch by right-clicking on this return value and splitting it. And we're going to right-click and make a rotator. And we're just going to plug the yaw into this. Now with this return value, we can get the forward vector for the move forwards, and then we can get the right vector for the move right. Now we can select all of this and hit C to add a comment section, and this is our movement input. Now for the mouse input, we can right click and search for look up and also turn. For look up, we're going to use the add controller pitch input, and for the turn, we're going to use the add controller yaw input. Now we can just connect up the execution pins and the axis values. And once we've done that, we can select all of this and hit C. And this can just be mouse input. Now let's go ahead and make it so we can spawn as the base character. In the content browser, I'm going to create a new blueprint class, and it's going to be a game mode. I'm going to name this Paragon Game Mode BP. Inside this blueprint, we can assign the default pawn class, and we can choose the base character here. Now to assign the game mode, we want to come up to Settings and then World Settings, and we can drop down the game mode override and choose the Paragon Game Mode BP. Now we can hit play, and we can see that we spawn in as the base character. So this character is obviously not animated yet. We're going to be setting up an animation blueprint in the next tutorial, but before we do that, we're going to set up some functions inside the base character blueprint that are going to help us set up our animations. The first function we're going to create is a function that calculates the pitch and yaw of our character so we can use it in a name offset. Let's come inside the base character blueprint. Let's add in a new function called calculate aim offset, and we'll start by adding in a new variable, and we're going to name this aim pitch, we can change the variable type to a float, and we're going to put in a category named animation. Let's add in one for the yaw. We'll just call it aim yaw, and we'll click and drag this into the animation category. Let's drag out the aim pitch and use a set. We'll hook it up to the execution pin, and we'll do the same for the yaw. Now to calculate the pitch and the yaw, we are going to get the base aim rotation, and then we're going to get the actor rotation. With the return value of the base aim rotation, we're going to drag it out and use the delta rotator function. For the B input, we're going to plug the get actor rotation into this, and then with the return value, we can right click on it and split it to gain access to the pitch and the yaw. I'm just going to select my two sets and move them across to make some more space. And what we want to do here is apply some smoothing to the aim pitch and the aim yaw. To do this, we can use the finterp2 function, which stands for float interpolation. We're going to use the aim pitch for the current value. The target is going to be the pitch from the delta. The delta time, we can use a function called get world delta seconds. And the interp speed can just be a value of 10. The higher the value of the interp speed, the faster the smoothing is going to be. Let's do the same for the yaw. Let's drag this out and use the finterp2 function. The current value is going to be the aim yaw. Target value is going to be from here. The delta time, we can use the get world delta seconds, and we can use an interp speed of 10. Now when we run and look behind us, we're going to notice that the aim offset is going to jitter. So to fix this, we're going to reset our yaw back to 0 when we go past a certain angle. So to make this happen, I'm going to make some more space for the yaw by selecting the yaw nodes and moving them over to the right. I'm going to break the link on the target and delta time by holding left alt and left clicking on them. We can duplicate the get world delta seconds over here. And now the target, I want to get the absolute value of the yaw. So I'm going to type in ABS to get the absolute value. And then with this, we're going to check to see if it's greater than a certain angle. So we can use a float greater than float, and we're going to see if it's greater than, let's say, 130 to start with. Now we can use this to switch between the values that we want. Let's drag out the target and type in select, and we can select the value based on this result here. So if it's greater than 130, we're going to leave it as 0, but if it's not greater than 130, we're going to just get the yaw from the delta rotator. And that will fix the jittering for us. Now one final thing we want to do is return the pitch and yaw in the output of this function. So we'll select the purple node and hit a new parameter on the output. We'll choose a float, and this can be the aim pitch, and we can also output the aim yaw. Now let's just move this node all the way to the end, and we'll hook up the execution pin, and we can plug in the returns on the set of the aim pitch and yaw, or we can just plug in the variables from the variable tab. Okay, and that is our calculate aim offset function complete. Now let's move on to our next function. When we move and turn as our character, we want them to lean in the direction that we're turning in, and this function is going to help us to do that. Now let's go ahead and add in one new function. We can name this calculate lean. We're going to add in an input parameter for our lean sensitivity. We're going to make it a float. We can just name it lean sensitivity. And now let's start by getting our actor rotation. Just going to move it down a bit, and we can promote this to a variable and store it as our previous character rotation. I'm going to move this up towards the end, and we can double click on the wire to add a reroute node. Now let's drag out the previous character rotation and use a get. We can drag this out and use a delta rotator. We'll hook up the get actor rotation into the B input, and then we're going to split the return value. We'll drag out the yaw and we'll multiply it by a float, and we can hook up our lean sensitivity into this. Now we can go ahead and promote this to a variable, and this can be our lean amount. Hook up the execution pins here, and if we want to apply some smoothing, we can do this by dragging out from the set here and using the finterp2 function. The current value will be our lean amount. The target value is going to be from the multiply. Delta time, we can use the get world delta seconds function, and the interp speed, we can just use a value of 10. And one final thing we can do is return our lean amount in the output. So we can just name this lean amount, we'll make sure it's a float, we'll hook this up on the end, and we can either use a get from the variable tab, or we can just hook up the return from the set. Now to wrap up the tutorial, we're going to create one final function. It's going to be easy, it's just going to be called calculate speed. We are going to get the velocity of the character, And we're going to drag this out and use the vector length function. And this will be our speed, but we're going to return this in the output. We'll just name this speed. We can hook that up straight into there. Okay, and now we're ready to move on to setting up an animation blueprint for one of the Paragon characters.